Hello, Namaste. This is Rohini Merugu talking about reconfigurable antenna. At the end of the video, you will be able to explain reconfigurable antenna. You will be able to list the applications of reconfigurable antennas. Now, the question comes in our mind, what is meant by configuration or reconfiguration first of all? So, configuration is, as we know, as per the dictionary meaning, it's an arrangement of the parts or the elements in a particular form. And when I use the word re before it, reconfiguration is to rearrange the something in an altered form or configuring it again in a new way. That is the reconfiguration. The reconfiguration antenna and smart antenna are completely different. There is a difference between the reconfiguration antenna as well as the smart antenna. The reconfiguration mechanism lies inside the antenna, whereas in smart antenna it is in the beam forming network. So there is an external beam forming happening in the smart antenna. So that is a smart antenna, whereas reconfiguration is inside the antenna. So reconfiguration capability of the reconfigurable antenna is used for maximizing the performance of the antenna in changing scenario. A reconfiguration antenna is an antenna which is capable of modifying its frequency, radiation or any other parameters dynamically in a controlled and reversible manner. Remember, the word is very important. It should adapt to the frequency and radiation properties or other parameters in a reversible manner as well as in a controlled manner. So reconfigurable antenna differs from the smart antenna because reconfiguration mechanism is lying inside the antenna, whereas in smart antenna it is in the external beam forming network. So this is a simple diagram shown, or the view has been given of the reconfiguration antenna. So this is the actual reconfiguration antenna and its internal structure is shown here. So these are the different multiple antennas been mounted, and these different antennas, how they are connecting to each other, that forms the reconfiguration antenna. So reconfiguration antenna allows reducing the number of antennas present in a given device, ensuring the interoperability between the antennas. So reconfiguration allows an antenna to adapt in the real time, but the different parameters like resonant frequency, polarization, radiation pattern, etc. So here you can see I have shown the array or MIMO antenna on this side, and on this side there is a reconfiguration antenna. So here this multiple input, multiple output kind of antenna, number of antennas are connected, that forms an array, and there is an antenna selection network. But the reconfiguration antenna is not like this. It is a different one. So here you can see A and B together is forming one antenna. So these antennas together configure for a particular antenna parameter, that is the reconfigurable antenna array. So this is one antenna, this is another antenna, so this is forming an antenna array. Reconfiguration antennas can be classified according to the parameters that they are configuring or adjusting. So like that, there are frequency reconfiguration antennas, radiation pattern reconfiguration antennas, polarization reconfiguration antennas, compound reconfiguration antennas. Compound means more than one parameter reconfiguration. Let us see one by one. Frequency reconfiguration, where antenna can adjust dynamically for the frequency of operation. It is useful in the situations where several communication systems converge because the multiple antennas required can be replaced by the single reconfigurable antenna. So here we are replacing the multiple antennas by a single antenna which is reconfigurable. Frequency reconfiguration is achieved by modifying physically or electrically the antenna dimensions. So we are adjusting the antenna dimensions physically and electrically by using the RF switches or impedance matching or tunable materials. But this is reversible manner. Remember, it's not permanent kind of dimension change. It is a reversible and a controlled way. The antenna can be developed by two mechanisms, either electrical or mechanical. When I use electrical mechanism, it uses the discrete tuning or continuous tuning method. When I use the discrete tuning method, there can be the RF switches we can use. If continuous tuning is required, we can use the varictor diodes. In the mechanical mechanism, the impedance loading tunable materials are used, such as the liquid crystals, metasurface, to achieve the frequency reconfiguration. Metasurface is a metallic as well as the dielectric material surface. Another kind of reconfiguration mechanism is a radiation pattern reconfiguration. It is based on the intentional modification of the spherical distribution of the radiation pattern. Pattern reconfiguration antennas are usually designed using movable or rotatable structures like metasurface, or including switchable in reactively loaded capacitive elements for intentional modification of spherical distribution of radiation pattern. So by using movable or rotatable structures or by using switchable structures, we are achieving radiation pattern reconfiguration. These antennas are capable of switching between the different kind of polarization modes. It has a capability of switching between the horizontal, vertical polarization as well as circular polarization. Reconfigurability can be provided by changing the balance between the different modes, such as multimode structure or metasurface. To reduce the polarization mismatch, losses in portable device, switching between horizontal, vertical or circular polarization is needed. Now the another kind of polarization reconfiguration is the compound reconfiguration. Compound reconfiguration is the capability of simultaneously tuning several parameters such as frequency, radiation pattern, etc. The most common application of compound reconfiguration is combining the frequency agility and beam scanning to provide improved spectral efficiencies. Reconfigurability is achieved by combining the same structure, different single parameter reconfiguration techniques, or by reshaping dynamically the pixel surface. Different types of reconfiguration techniques are there, such as electrical, for example, RF MEMS, spin diodes, varictors. There are optical techniques that are physically changing by mechanical methods, or by using the materials such as solids, liquid crystals or liquids. Like this, there are different possibilities by which we can have a reconfiguration antennas, either by using the electrical methods such as RF MEMS, spin diode, varictor diode, fates, or can be optical methods where we can use photoconductive materials, or can be mechanical methods where we can alter the structure, or there can be different materials can be used like metasurface, liquid crystals, or ferrites for achieving the reconfiguration antenna. So we got the insight of what is reconfiguration antenna, and now let us see where these can be used. These antennas can be used in cognitive radio systems, in MIMO systems, in satellite communication, in biomedical applications. Most of the biomedical applications use reconfigurable antennas, and military applications is one of the broader sector where reconfigurable antennas are used, and in industrial applications also the reconfigurable antennas are widely used. These are the references used for preparing this. Thank you.